Welcome to our structural modeling project additional March extra session where we're going to discuss topics, and the topics will be introduced and the discussion led by Kevin Dye. So Kevin, it's yours.
Well, we've had a lot of sessions about the technology and the mathematics of structural modeling, and I thought it'd be useful to speak from the other side of the prospective uses of structural modeling, especially for modeling systems. And there's some questions that come up in using structural modeling for systems modeling. One of the most persistent questions that people like to ask is that they're interested in modeling intransitive relationships in systems models, and you can't use structural modeling, at least with the mathematics we currently have, for doing that. And so some people attack structural modeling because it doesn't model intransitive relationships. I would argue that it's the wrong question, actually, because structural modeling is specifically worrying about the long-range relationships across the entire system that's being modeled. And if you're interested in intransitive relationships are by definition localized. They don't propagate. That's the meaning of intransitivity, is that they do not propagate. So they're localized, they're just attached to a node, one link. If you have a relationship that spans more than one link, then it must have a transitive property. And so it's a question of where the modeling is done. Right now, we don't have integration of structural modeling into systems modeling tools. And the functional way you deal with this is you do your structural model, and that gets entered. Usually you have to manually enter it into the systems modeling tool. And then if you want to add on localized intransitive relationships, you just do it in that tool. You don't try to do it in the structural model. But this is kind of a typical question that comes up when talking about using structural modeling to establish the baseline for models and other representations. But there's other ones, and so I thought we might talk about some of that. Is anyone familiar with SysML, the systems modeling language? Has anyone used that?
A little bit.
How about UML, which it's based on, Unified Modeling Language?
Quite a lot in the past.
Yeah. So over the past 3 months, we went over kind of three of the primary relationships that would allow you to use structural modeling to do a UML or a system modeling language based model. So that's aggregation or part of relationships. We had a presentation on NOMAL, the part whole. And then there was the type of relationships, which are class hierarchies, and then the influence or functional relationships, which in object-oriented modeling are referred to as methods, the relationship between objects, other than hierarchy or type. So I wondered, Joe, did you ever consider using or think about using structural modeling for a UML to generate a UML model?
Is that a question for me, Kevin?
Yeah.
Yeah. So in the technical report, the last one, we referenced some work out of Sweden for methodology, and also got a reply actually from the author of that book, pointing out the relationships and similarities. He read that paper and some of our other papers. And so what they do with concept base is they set up a system that includes symbols. You know, UML is just a symbol set. You have to map everything over it. So we've got symbol sets and work that up. So yeah, that's kind of the area that I'm looking at. Is I'm looking at using the work that's been done by these folks in Sweden and other places for that integration step.
What was it called? Meta methodology?
Let's see, give me just a second here, and I'll tell you exactly what it is. You can go ahead and talk. I got a minute.
Well, for these three primary relationships, aggregation, class hierarchies, and functions, we often use structural modeling's most often been applied to the functional modeling in the guise of influence diagrams, but it hasn't been.
Kevin,
yeah.
While Joe is looking for that,
I found it now.
Okay.
So I guess I could bring it up on the screen, but the name of the book is Meta Modeling for Method Engineering. And this is like the third thing I think that you were talking about.
Okay.
And let's see. Let's just go ahead and bring up the, I'll just bring up his email. It'll probably be the easiest thing to do, because he has some links in there. And there were really some good, there's some good references that he pointed out that made direct connections to what we were doing here. Right, and so he let me share this. He titled it Transitivity, Symmetry, and the Like, right? And so let me go ahead, bring up this one. Yeah, it's good. Everybody see that? Make that bigger.
Make it bigger. There you go. That's good.
Okay, so present everyone. Everybody can see it? Okay. So let's see. This is one of the authors here. So we talked about the report from last month, right? General Systems Context. And what he pointed out was some of their work in the concept base. And I think this one right here is the most interesting. And you can, so they have defining the semantics for the link types that you're talking about in the models. They've done all that work. And really the only thing that I think would probably add to this is they're talking about ancestor, right? Person has an ancestor. It's asymmetric and transitive, but it's also irreflexive. So we would probably expand this and make sure that in every case we put all three aspects of the AMEI into it. So that makes sense?
Yeah.
And so the work is referenced in TR in the last technical report.
Can you zoom in on the graphic there?
Sure. Let's do that. Let's go and see if we can make this bigger. That good?
Okay.
But they also include ontologies. They make let's see, yeah, they require 4 things: goals, ontologies, processes, and notations. And notations like UML and SysML are just symbol sets, and you have to map your ontology over those symbol sets, and then you put the processes in, and they take it all apart and provide the framework for doing that. As I said, this is pretty much what I have in mind, except that we'll want to make sure that in every case we use all 3 logical properties. That reduces complexity and reduces uncertainty.
So is this software do they have an API for it?
Oh yes, it's so in the email that I distributed. Let's see, I distributed this to the list, and so here is the concept-based software at SourceForge. He gave a link to that, and this is a paper basically there that explains it. It's open source software. And it just kind of goes through and talks about it, what it is, and so forth. The book seems to be a preprint, or the book seems to be available there also at that site.
Is this, sorry to interrupt, is this in the realm of what is called the semantic web?
No. Well, okay, so that's an excellent...
Because I find some similarities. I'm not very 100% familiar, but...
Okay, that's really, really a good question. Once you go back and you get into the logical properties, and you make sure that you're using all 3, transitivity, reflectivity, and symmetry, then you can translate any of this type of work through common logic into a wide array of logical representations, including almost all of the representations of the semantic web. Because as soon as you go back and start working with the logical groupings, right, then your propositional first order logic, then you can move that through common logic, and then common logic you can map to many different things.
Okay.
Yeah.
So a difference in using the semantic web versus the way we just have a link structure on the web today is when people make a link between pages, there's no natural way to create a path between multiple pages except you do one at a time. And so that's a big difference between using structural modeling to generate a semantic web versus just putting up links on web pages is this propagative aspect. Then the other thing that we need is that the links have some type. The links mean something, like one is based on another somehow, rather than another relationship, which is one is similar to another, or one is a function of another. We need to have typed links, and then if you're in a system that respects the principles of semantic web, then you can use structural modeling to create networks of connections that have some meaning. Whereas right now, there's no natural way to ensure there's some meaning to the network. It's just someone might have created a link from A to B because it's similar, and they created a link from B to C because one is more general than the other. And then they created a link from C to D because one's a function of the other. And so there's no natural propagative path. There's no meaning to the path.
Well, I think what I call the semantic web is a development where two things have where the relation is qualified. So I haven't gone very much deep in there, but that was meant to be the future of the web, where things could be connected with a qualified relationship. So it means that you can define the link. So is it symmetric, transitive? I mean, so that's why I asked the question. It seems to me quite similar to what I have seen, but as I said, I haven't gone very deep in the semantic web, which was not very developed at the time that I was, being curious about it, and I'm not either. I mean, in the modeling, very aware of what's going on. So I'm listening now today.
No, I think you made a good observation. Janet was going to make a point some time ago. I didn't want to lose her thought.
Right. I was going to ask about the, you mentioned the methods in UML being related to the influence idea in ISM and and functional relationships. And I was wondering, what kind of diagrams do you use in UML that shows method relationships?
I haven't used UML that much myself. I was referring even earlier to just the different object-oriented formalisms that preceded UML. That's the last time I actually modeled with object-oriented diagrams.
So is there a particular method modeling approach that you could reference here? I'm not familiar with that. I'm familiar more with the idea of the class, the part whole breakdown and the class hierarchy.
Yeah.
Let's see. I can try looking it up. I was also interested in your, we read Peter's transcript of your talk last time, which was very interesting and coherent. And thanks, Peter, for doing that. I don't know if you've seen it, Kevin. It reads quite well.
No, I haven't seen anything the past few weeks.
Okay. And you were mentioning IDEF, which I think that's also an interesting connection, because the functional modeling, as I understand it, in IDEF 0 is difficult for people to grasp. They tend to, I guess the distinction between functional modeling and behavioral modeling is often difficult for people to grasp. So it's just, yeah, I'm just saying that your focus on function, influence, methods, I think it's a deceptively simple seeming topic that hides complexities and confusion. So I'm glad you're focusing on that.
Well, what I remember of the functional modeling was it was the only time you drew arrows between objects that weren't vertical.
Right, right. And I think what I had read about that is that people, when they see the arrows, they tend to think in terms as if it's a flow diagram, which is what IDEF2, or the they put a
the functional flow block diagram.
yeah, right. And maybe they prematurely identify structural components with the functions. This is not directly on topics, just that I think that that there are some subtleties. Maybe ISM could supplement the use of other functional diagramming methods to separate out the structure, the functional structure, from the behavior. So just a vague thought.
Well, I'd like to interject something here if I could. And so we did a few years ago, back in the early 2000s, some folks did some work on exactly what you're talking about, Janet, about how people interact with these diagrams. There's a fellow who was the chief engineer on a software-defined radio. He was a software guy. He was also a hardware guy. He had both, came out of both areas. He was a lead, and he was using IDEF zeros and UML at the same time to describe the functions for the radio and what it had to do and so forth. What intrigued him, what he found out, was his software engineers could not understand the IDEF zero. His mechanical engineers could not understand the UML.
Very good. Yeah, great point.
And so what he started doing was saying, well, there's different types of people that view things different, just fundamentally view it different. Mm-hmm. But what he also pointed out was there's a direct mapping between those two. And so if all you need to do is have some kind of psychological test that says, oh, these people see this information this way, and then present it to them that way. And to say, oh, everybody's got to use UML or everybody has to use IDEF zero, just forgets the idea that we all perceive things differently. And I have some of his papers available if anybody's interested in what he did and going and publishing in that area.
Yeah. But I think it occurs to me that one of the implications of using structural modeling as a front end for these modeling formalisms is that there may be a useful de-skilling that results. You have to be quite expert to be doing these diagrams, but if instead all you had to do was answer a bunch of questions, you may not have to be as skilled. And it may make it easier for people to go across formalisms that they're not that comfortable with.
Right, and then they could learn through that to gain insight into the one that didn't come naturally or that they hadn't been trained in. Yeah.
Yeah, they may get more of an intuitive feel for what it means by being paced through the formalism. I mean, right now, a lot of modeling tools, it's a blank sheet and you start drawing, and when you draw, you tend to try to include all the objects that are close to the thing that you're modeling, and you don't worry about the overall system as much because you get drawn into the detail of the local. And so in addition to being able to maintain a focus on what propagates across the entire system, it may also help people overcome just what all the boxes and arrows mean, because instead of having to interpret an arrow, they have to answer a question.
I think those 2 points are really quite critical, Kevin, this issue of promulgation and the tendency with the tools to encourage a narrower focus, possibly.
Yeah, they encourage a narrower focus because the things that propagate the system are on other pages in your system. You have to change the page of the display that you're in, or change to in order to connect a propagative relationship. And so that the natural tendency will be just to stay on the page that you're at and fill in the details.
Would it be different if you had a whole wall that you were working with, that you could use a, SysML or UML on literally a whole, physical wall that would be, 30 foot by 10 foot or something? I mean, the limitations of framing in a screen is a constraint in perspective that could lead one to this problem, essentially.
Yeah.
Well, that was one of Warfield's pet, complaints, was that people tended to limit their models to the size of their sheet of paper. Right. And yeah, so now I've looked at things with the, smart whiteboards. We don't really have any place for it now, but the the idea of having that kind of technology, and he would have really gone to town with that, I think.
I think it's something to really think about, actually, because I mean that, I've tried to work with SysML and UML and NoMagic and some of these software programs, and I had this sort of intuitive sense of what you're now expressing was those two things. Was one, it was like I felt, God, I can't work in the screen, and the other thing I felt was like, well, it's two-dimensional. I mean, that was another problem, of course, but it didn't give me the tools necessary to express things. I mean, I remember doing a rich picture at the Open University in 1979 on a massive wall with a big sheet of paper, and we were all at there drawing it, and we drew this model, and the collective sense of model building was a very strong emotional event, actually. And I think there's something really to that in terms of collaborative model building when you get then a shared perspective in a rich picture.
Well, in structural modeling, the way you get the shared modeling experience is you present this, at least the way it's currently done in face-to-face sessions or synchronous online sessions, is everyone is presented the same question at the same time, and then they debate that question, and then they come up with an answer. And so the collective modeling is very incremental, whereas what you're describing was very parallel. They're kind of building the whole thing at once.
Exactly.
Right?
Kevin, do you work with large scale displays, smart whiteboards, that kind of thing?
No.
So
I'd love to, but I don't.
Mm-hmm. I have a feeling that these massive displays have never really found their killer app, and to some extent, ISM might be the killer app for the these boards, because they're fantastic. They're huge. What's available now is just astounding. I wonder if one could have a NSF proposal, or maybe approach a manufacturer, Peter, and say, we are going to, bring the killer app to your technology so that people can really see the benefit of it.
I think that would be another interesting project to go off from what our discussions here, and I do get these kind of magazines and things about video walls. In fact, I was looking at one this morning. It's sometimes, so I'll go and find. I think I put it somewhere. I'll see if I can find it. But that would be a really fun thing to do.
You mentioned. Go ahead, Helene.
Yes, sorry. I thought that there was something very important about the fact that people can't really get into a diagram that doesn't correspond to someone's, constructive process, let's say. And you talked, Kevin, about incremental and building things incrementally.
Yeah.
that's something that in the pattern language side of things is very important. The fact that the elements that we're putting together are discrete in a certain way, so that so that each relation can be questioned. And this is part, I think, as you were mentioning, that you asked the same question to several people and they discuss it, is that actually it is about questioning each relationship or each additional step in building a model. But then you run into the problem that you can only do that, as Janet was saying, or you were saying, that you're building with what you have around you locally, and you lose the bigger picture of things. Just a remark here about the incremental, the necessity of having an incremental process of inquiry, and the need at the same time to have something that flows and shows a bigger picture.
Yeah.
I don't know if it makes sense.
Yes, no, that's exactly what structural modeling tries to do, is lets the computer keep track of the evolution of the big picture, and it guides people to just very specific pairwise questions of, does A have something to do with B?
Okay.
And because if you try to have a group discussion with more than 3 objects,
yeah, you run the maximum.
Difficult.
Yeah.
They don't. There is work in repertory grid analysis, which is the work of George Kelly in constructivist psychology. They ask if they present 3 things at a time, and they ask how are 2 of them the same and the other one different. And they have a good track record that people at least answering individually can keep track of 3 things and the relationship between three things at a time. Isn't that, as Warfield wrote in his paper, the magic number 3 plus or minus 0? If you're dealing with 3 things, you have A, B, and C as the nodes. You have the relationship between A and B, B and C and A. And then the relationship of all 3 things to each other. That's 7 things, and that's the average number of things people can remember. 7 plus or minus 2. So keeping track of the relationship of 3 things seems to be the max. And just Warfield chose to have a productive discussion around the relationship of 2 things. Now we've never had we've never done structural modeling where we ask the relationship of 3 things. But still, even if we did, it's a very incremental approach compared to what Peter's describing, where people are doing things all at the same time. But something that's happening now with the online software development we're involved with is we're getting the online equivalent of the big wall and everybody working at once, because we want to go to an asynchronous, decentralized algorithm. So instead of everyone answering the same question at once, people can answer these questions incrementally, and we construct the matrix in a parallel fashion with multiple small answers, and in a more fragmented way, and that's closer to the idea of drawing things on a big wall. Because when you're drawing things on a big wall with a bunch of people, they can't all talk to each other at the same time. They can only talk to who's next to them at their shoulder, and that's similar to being online and asynchronous. It might be it's interesting insight that Janet has, that this might be exactly a type of application the giant displays could use.
Yeah, it's exactly the same type of problematic that you have in when you want to keep track of asynchronously conducted projects. Well, I was discussing with people like who were building open architecture. And the big problem was that people were coming and going and never knew at which stage they were and what needed to be done and where were the gaps. And so we were starting to think that a killer application would be a way to keep track of tracks in a kind of a stigmergetic way of representing where things were at and what needed to be done and things like that. So it's a different universe, a different domain, but I think the problematic is similar. I don't know if I made myself understood here.
Well, I think it's an interesting problem area, especially with large groups of people that are working concurrently and distributed. I can relate some of my experience just as an anecdote, but in one project we had a facility that was constructed for us to work in. In the center of that facility was a large conference room. We had dueling whiteboards. We had these electronic whiteboards on two walls, and then we had physical whiteboards that were deep. You know, you could slide them back and forth on the other walls. And that we bring people in, and we try to organize around the topic, do interviews, ask questions, things like that. What we found was each person that came in brought their own context and their own language, and it was extremely difficult to normalize that. There was no real way to normalize the concepts or the language among these groups, bringing them in one at a time. So what I did was, you know, it's a about 50 or 60 foot square room and had a hall around the outside. So what I did was I had the draftmen draft a very simple process out of a manual and paste that on the outside wall, and then gave everybody basically marking pens and said, go mark this up where you think it's different. Try to get something common. So we actually used a big sheet of paper that was basically went almost all the way around the whole process, the whole room on the outside in the hallway, and let people go and write their what they thought it was. And then people could read that, and we could have discussions about that specific concept. So I think there's advantages and disadvantages, and the most important thing to happen, I believe, is you have to have some place where people or some mechanisms develop a common understanding of the words and concepts.
Yes, or at least a mutual recognition of differences.
Well, there needs to be some type of common lexicon.
Yeah.
Because without the lexicon and the conceptual sharing of concepts, you just have a collection of common symbols, which means nothing.
So maybe we
I
should
think
go
the
back
issue
to.
of, sorry. Oops, sorry.
No, I was just going to say maybe we can get back to Kevin's
Yeah.
talk. But maybe say the last thing you wanted to say there and then get back.
I was just saying, wanted to bring out the permanence of the mutual understanding or common meaning whether this is something that is very ephemeral in the sense that the understanding is there on the spot and it can help get to the next point, versus bringing it back into, you know, each respective bubbles and accepting it as a change. That was just a thought that came. Yeah, let's get back. I don't want to distract the conversation.
I think Joe raised a kind of fundamental point of how we've done structural modeling, which is, or how it was designed, which is that you have a group of people, you know, usually 12 to 36 people, and you give them all the same question, a straightforward question, and they're just debating yes or no. And they go through that all together and end up with, you know, and the computer keeps track of that model, and they're presented that model either as they go or at the end, and that becomes the common model. And we have good evidence that it's usually not aligned with anyone's individual model. So that's one difference from earlier work on modeling, where they would talk about mapping someone's mental model. And what we're doing in structural modeling is deliberately not modeling someone's mental model. We're asking about the system relationships, and we're kind of presuming, and the evidence is that it rarely matches someone's individual model. And that's the point of doing it. And it's also the reason that we try to design, when we do an event, we try to have people that have very different perspectives and disciplines. We won't bring all the same same background of people into an event. We mix it up to deliberately force different perspectives together. But last year we were responding to a call in the European Union framework program. They had grants for collective intelligence, and they especially were interested in going to scale. How do you do modeling with thousands of people? And one of the questions that comes up challenges the model that Joe just referenced, that we need to have, we have this drive towards having a common model. Well, if you have thousands of people, can you really have a drive towards awareness of a common model? And is it necessary? If you have people that are familiar with pieces of the situation and they overlap just enough with another group of people familiar with pieces of a situation, is it somehow meaningful to have an intelligence that emerges at a larger level? So that's kind of this discussions we've had in the development of the online. We have a mobile application for doing structural modeling called Idea Prison. And that's one of the questions as we deploy it. One model for deploying it is we don't use the structural modeling algorithm to create a single model that everyone's responding to and asking questions about. We have hundreds of models and different ways of aggregating them. That's kind of a...
Sorry, I didn't... I think this is crucial and critical because it kind of brings the question of agency itself and knowledge, and fragmentation of both knowledge and agency, and that necessarily you have people that have a piece, you can say that taken all together, collective intelligence is the sum of pieces of knowledge and capacity for action that come together. And so, to me, or from my perspective of research, and I'll be very interested if maybe at another occasion you could share with me some of this. This is towards which we need to go in order to leverage all potential knowledge and agency, and be able to get these different skills and capacities and knowledge to actually, yes, go examine what overlaps and then what coherence can be built from it. So it's very interesting, this question, this scaling thing.
Yeah, coherence is a good word. The traditional way we've achieved coherence is by having people respond to the same questions and looking at the same results and developing a shared memory. And now the question of coherence is when you're interested in going to scale is different. And the one reason we want to go to scale is to start to use structural modeling in the political realm for deliberative democracy as a way of structuring dialogue among citizens. And if you want to engage the citizenry, you have to be able to go to thousands of people. The structural modeling is typically only done a couple dozen people at a time. So that's kind of the current horizon.
Yes, exactly. And I think that there's a mistake that's done, that to try and find cohesiveness, which is the shared view that you have in a smaller group, which is more or less homogeneous in terms of perspective and worldview, in comparison to bring together non-homogeneous and different perspectives and worldviews that yet can be coherent. So that's the difference between cohesiveness and coherence.
One of the techniques we've been talking about on coherence is measures on an individual participant's level of coherence of the whole, and having kind of coaching system based on how much have they engaged, how much time have they spent, how many ideas have they looked at, how many comments have they made, how many votes have they made on other people's ideas, how much structuring have they done, and then based on some composite measures, coach them to suggest that they answer a question. Because in the structural model, if we have more people answer a question between idea 136 and idea 234, we'll be able to connect two clusters of ideas. And so we know that a certain percentage of people, maybe 10% of people will respond to the question, but we send it out to people that are poised to answer that type of question and get enough sample of a sample of enough people to get a response on that particular relationship. And so we're actually calling this coherence measures.
Well, we have about 10 minutes left. Is there any specific things that we'd like to cover in the next 10 minutes?
I'd like to take a few minutes to talk about the project that Peter was working on, because it's a nice opportunity for applying structural modeling, the one on the ocean sciences.
Go ahead.
Yeah, so were you working with a group to develop that? Were you in the center of, or part of the group that's developing, or you were made aware of it some other way?
No, I've been very much involved in ocean literacy for the last 14 years or so, and and also earth science literacy, and there's one called network literacy, which I'm aware of and not been personally a part of. But the reason I brought it up is because that is a concrete example of an output from a collective activity, and the same with earth science literacy. And the reason that I'm here in this conversation and ISSS and in COSI, one of them is because I had and I still do, has this idea that we could develop systems literacy. And in a way, I would like to apply all that we've been talking about to the process of creating a guide to systems literacy, which has similar characteristics to the ocean literacy, earth science literacy, atmospheric literacy, climate literacy documents, which is a representation of a collective effort to establish some big ideas that a group of people think are important. So that was the context.
Yeah, as I looked at what was done on the ocean literacy, it looked like they had created an outline structure, almost like the outline of a textbook. And the outlines tended to go from more general things to more specific things. But it wasn't structured in terms of, what did I forget what you called it, learning?
Well, there were learning progressions, yes. I mean, the first work was to define, to have a definition of what ocean literacy is.
Yeah.
And then to go to that, and they created, or we created, something called principles, and then concepts, which were supporting the principles. From that, then became an exercise in developing learning progressions for kindergarten through high school in 4 grade bands under each one of the 7 principles. Now, that, in a sense, as I think we discussed, is sort of almost like a curriculum development. The idea being is that you build one idea on another. So that's what resulted. That's what's there on the website at oceanliteracy.net.
Right. So are you going to try to do that type of thing with the ISSS, a committee on the ISSS or something? Or are you going to launch a project?
Well, the project is sort of semi-launched. I mean, in a sense, I have been doing it with ISSS and also within COSI, and had several workshops on it. And Helene and I have written a paper on the relation between the pattern literacy for systems literacy. And so, yes, if there's a way that we could use any of the tools that you've talked about, or any of the processes you've talked about, to develop systems literacy that could cut across the boundaries of systems engineers and system scientists and cybernetic people and social scientists and complexity systems people, it would be a very fascinating exercise. And I don't know whether it's the idea prism or what tools that can be used. So yeah, any that's part of why I'm here learning all of this is how can we use the tools on ourselves to determine what is most important. I mean, there's something called the Next Generation Science Standards, cross-cutting concepts, which are 7 great topics that could be expanded upon. And one of them is models, systems and system models. But any understanding of modeling to the depth and breadth that we're talking about it, in all of its shapes and sizes, is not something that's part of a learning process that I'm aware of. It's more elemental.
Yeah, and what I'm trying to bring in the process is to try and see how patterns as the unit of meaning making, which our cognition is actually made of, how can we leverage this in various modeling, simulating, dialogue, etc., in order to build this understanding or get to this collective or larger scale modeling. How can we, yeah, that's what I'm looking at.
Even on a local basis, how to get the population of Quincy or Boston or Greater Boston to have an understanding of the issues that are affecting resilience in the face of pressing changes in the planet, and come to agreement, about the nature of the problem and actions that are needed, as a way to perhaps make it locally immediately relevant, Kevin.
Yeah.
I mean, NOAA has used, and Aleko used it with national fisheries at NOAA many years ago.
Yeah.
And so there is some experience there, and I would love to have sort of an ability to promote the application in a number of different areas. So anything we can do would be much appreciated.
Yeah, it'd be nice if we could do something that was maybe a mix of some face-to-face and online work to develop the systems literacy. Do you think there's any books that come close to all the definitional work you're interested in?
Well, there's a lot of different. You mean in systems? There's an awful lot of system books, yes. But I think the opportunity, is there in Corvallis, possibly in the summer, to do a workshop on this very topic, because I have a lot of contacts there in the ocean and earth science arenas, and I would like to bring that knowledge base into the systems conversation, because I feel that that's my credibility, in a sense, in that I've done this work with the ocean and the earth, and I would put in water and earth, and air and living processes into the systems literacy discussion, because it makes it a real, then it has a reality to it that is present. Janet and I have talked about this as well as a way to bring forward, Warfield's legacy and the work that the Simpsons are doing and your work you're doing. So let's hope we can do something.
Did you say Corvallis?
Corvallis in Oregon State University. Yeah.
Oh.
Well, we're getting down to the end of the hour. This has been very good, very interesting. Thank you, Kevin. Really appreciate your insights and your information. And I think everyone on the team has really made strong contributions. I think it's wonderful. So the next technical report, I think, may address some of the issues that were raised today, maybe in a little different way. And there's some fundamental things that I want to bring out and discuss. And this is just great. So anything else anybody would like to say before we sign off? Okay then. Thank you very much. Wonderful. I'm going to send out.
Thank you.
I'm going to send out a copy of that UML paper I discussed in psychological impacts and what that means, that work. And then also send out the pointers to these lists and the meta modeling for method engineering references.
Are you referring to the George Kelly paper or not?
No, actually, the paper I'm referring to is done by it's Systems Engineering Experience on a Complex Systems by Doyle and Penante.
Okay.
And it's interesting. It goes into the psychological aspects of how people just see things differently. That maybe is why they go different ways. Some very abstract, some very concrete. And so,
I'd be interested in what you referred to, George Kelly, constructive psychology. Was it you or Kevin who mentioned that?
Repertory grid, you mean?
Yeah, I mentioned it.
I'd be interested in if you have information on this, and I'll read the summary of last time that Peter just sent to me. Thank you, Peter. I was about to ask you for.
Oh, this, you were on that. You were on that email list.
I just sent it to the people here.
Okay, so I can find your email there, Lena.
Yes, absolutely. Yes, I'm Helen Finidori. Yes.
Helen. Okay.
And I'll look up what you. I might reach out to you also, maybe.
If you could send that actually to the list, I'd really appreciate it, Kevin.
Okay.
I did a lot of work on personal contracts theory way back when, and interestingly, there's sort of a connection to the work of Gordon Pask and conversation theory, and the work that went on in Brunel with all of that as well, and obviously the connections there between this and structural modeling of conversations, quite interesting.
Right.
Well, obviously, we have a very rich and deep area to continue to explore. And, let's see, when is the next one? It's going to be April, right? It will be April the 7th. And we'll try to get the technical report out beforehand.
Okay.
Thank you. Right. Thank you, Kevin, very much. Thank you, everyone.
Thank you. Thank
Take
you.
care.
Thanks.
Bye-bye.
Bye-bye.